Hello, and now we're going to be going over some Lisp programming. We had a couple homeworks for this as well. I put the description in the README of the repo of where you can download Racket. This is the program and interpreter that I'm using to run the Lisp code. So go ahead and take a look at that. So for this, basically what we're doing is we're using this programming language here to do a couple different test cases, just basic stuff, and see how the language interpreter works. You can look through the code and see how it's written. There's a lot of examples online as well about doing these very similar functions, and I wrote a lot of test cases as well, so if you want to test them, we can go ahead and look at that together. So I'll be running these test cases side by side with you. Unfortunately, I'm just going to try and copy and paste it in GitHub. I think when I do that, it'll mess up just because of the apostrophes. So we'll see. We'll do our best. So here we are. We're running the code right now in the Racket program. So let's try and run. We can run any of these programs at once. So I don't have to start with the test A of list length. I could start with occurs free and then go back to nth element and then jump down to vector sum, whatever I want to do. It doesn't really matter. It's just a running program. So I'll have to go back in here and change that. So now we should see that the list length returns 3 because there is A, D, and then this element, which is both B and C. You can see that this will also give a list length of 3. So we've got A, B, and C. Oops. You do have to be at the end of the line of the function you're calling after you pass in your function and parameter name. That's basically how it works. You have to call your function name first, and then any parameters that it needs. Let's go ahead and run through this. All right, so we see that. So let's do part B, nth element. You can kind of see through here, this just gives the nth element in a list. Pretty straightforward, but it's very interesting to see, and you'll see how this works in a second. Oh, it's going to happen a lot, so please forgive me about that. D. All right, so we got 0, 1, 2, 3. So that's the 3 in that element. I'm going to see in this one, we're looking for 3, but we actually only have a list of length 2. So if we use the list length and we gave it this list, as we see above, it's 3, but it's 0 indexed, so we'd be looking for something with index of 3, aka length 4, and this only has a length 3. So we'll say it's too short by 1 element. That's great. That's definitely correct. So now we're going to be looking at the remove first function. So we remove A from the list A, B, C, and now we have a list returned that's just B and C. We'll continue through it. We won't go through every single one, but just enough so you get the basic idea, and we'll start speeding up towards the end. Remove first B and EFG. Since there is no B in this EFG, we just return the full list. We can look through the example, remove A4 in here. It'll only remove the first instance of A4 in this list, even though there's 2 instances of it. So C1, A4, C1, A4 will return C1, C1, A4 because this one is getting removed. Same with this, removing X from an empty list, we'll just get the empty list since we don't have it. Occurs free. So, does this occur in this? Does X occur in X? We get true. That's what the hashtag T stands for, or pound T, whatever you want to call it. And this will most likely give us false since X does not occur in Y. Yep. You can use Lambda Expressions in here too, so you can kind of see how these would run. I did a couple of true functions just so you can see it. Part E, we did a substitute function. So you can see in here, we're going to substitute A and B in this long list. And now you see that every function of B, BC, BD, is now going to be AC, AD. You replace B with A. That's the substitute. Number elements from is right here. So we're looking for these elements, and we're looking for what number element they are in the list. Look through a little bit more of the code. There's a cursor free. It's very interesting to see how when you point your cursor over these functions and variable names, it'll be linked to the top if they were used as a definition. This is this. Number elements from this to this. And we just add them up. Alright, so list sum. This is just going to add these numbers in a list together. So let's go ahead and deviate from the path. Let's go ahead and do 50 and see what happens there. 60, so 1 plus 2 plus 3 plus 4 plus 50 is going to be 60. Vector sum. It's going to basically do the same thing. 3 plus 4 plus 5 plus 6 is going to be 18. Alright, duple 2, 3 is going to be giving 2 3s. Duple 4 of haha is going to give 4 versions of this list. Ha 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 ha. Very funny. Duple 0 of blah is going to return 0 of blah, so we get an empty list. And so let's actually just go ahead and run one of these just because it's funny. There we go, and then part J, sort predicate. So we're just going to be sorting these based off of whatever operator we have. So if we do a less than symbol, it's going to be sorting minimum to maximum. If we do the greater than symbol, it's going to be sorting from maximum to minimum. So we'll just go ahead and run both of those. So you can see that they work. There we go. All right, we're going to go ahead and go through the next set of programs. And here's a more fun program. This is homework 4 of the Lisp programming language. Basically, what we had to do was create a game throwing different dice. We had 3 different parts. Part 3 was just adding a GUI onto it, and I do have that working, so feel free to have fun with that. Part 1 was making a game where we're throwing 2 different dice, 6-sided dice. Throws of 7 and 11 are winners, throws of 2, 3, and 12 are losers. We just throw 2 dice and output what the user got. If they get the winning ones, we'll have a special designation, natural or yo, and then snake eyes, ace, deuce, and boxcar are the losing ones. So just call the same function dice1 over and over again. We'll continue to get some different throws. And then part 2 was being able to do the same game, but we define what is a winning and what is a losing value. So we can make 2 different lists of winning and losing. So let's go ahead and look through the code a little bit. And this is the part 1. We're just making the throw die random 2 different numbers of a throw. This is how we randomly generate the numbers for the dice, and this is how we throw those 2 dice. So throw die is the 1 dice, and throw dice calls throw die twice for throwing 2 different dice. Alright, so here's our first program part has the 2 winning numbers and the 3 losing numbers in the list. And if we have either 7 or 11, we'll win, 2, 3, or 12, we'll lose. And we'll just output what they threw. Then for part 2, we'll call this. So I give a couple of examples. We can have 1 through 5 be winner and 6 through 10 be loser. 11 and 12 will just do nothing. We can make evens be winners and odds be losers. We can make 2, 3, and 12 winners and 7, 11 are losers, which is exactly the opposite of the beginning one in part 1. And this is just how we go through it. You basically just call a list and go through over that. This part right here is just part 3. This is the GUI. This is putting on black disks of a specific size over a white square in Lisp. So it's pretty interesting. Let's go through this a little bit. So here we've got our code running. So let's go ahead and get this call. It's dice1. We'll go ahead and copy this so we can call it a couple times. So we got 6 and 6 right off the bat. 12 boxcars, you lose. That's a special combination. We got an 8, which is nothing. A 7, that's natural, you win. That's a 3, ace deuce, so you lose. 6 is nothing. 5 is nothing. 4 is nothing. We won again. We won with 11 this time. We lost with 2. So we probably already hit all the combinations. So that's part 1, and here's part 3. You can see the actual dice that you got. So you threw a 2 and 5, which is, there's the 2 and there's the 5 right there. So let's go ahead and run the second part, where we can make our own list. And it's pretty easy if you just copy it because you don't have to rewrite it out. So this is our list, 6 and 2. So we got 8. So we lost because this is the losing list. And anything between 6 to 10 is going to lose. So we'll keep throwing that. 10 we lost, 6 we lost, 4 we won, etc., etc. So you can keep going through that, make your own lists. Pretty fun program. And that's everything we did in Lisp.